Hi, my name is Jeffrey Hewitt. I'm a second-year graduate student at UCLA, and this is my final presentation for C204 Machine Learning, titled The Development of the Experience Day Training Bot. Here's our agenda. I'll be quick moment to look over. All right, so the idea behind this project was to use financial data from Yahoo Finance and the algorithms we learned in class, including industry standards like the MACD and Momentum Index, to try and figure out what the stock is going to do tomorrow based on what I've known it has done today. I could not come up with an algorithm or a method that adequately predicted what a stock is going to tomorrow, ultimately not outpacing just leaving my money in the stock and letting it grow over time. Therefore, I flipped the switch, and instead of having me predict the incredible unpredictableness of the stock market, I would allow the known data of the stock market to try and predict what I should be doing today. In order to do this, I built a value matrix or decision value matrix for every single decision cutoff, i.e. From a no gain cutoff associated with column H all the way to a 10% cutoff in the right-hand corner that you can't see on screen. An example of how this works is it looks at the value of the current time step, which is actually in row 6, and says, hey, the gains I just received, which is 0.995, is that greater than or less than the value that is associated with my column? In this case, it's less than, so it allows it to stay, the algorithm allows it to stay in the stock for that 24-hour period to receive whatever gains or losses happen in the next 24 hours. And it does that for every single column, every single row for the value matrix for the algorithm to make decisions on in the next logical step. This is what the decision wave sort of looks like. And it's important to note that if you had put $1,000 in the stock market, which is done for every one of these decision waves, at time 0, then it would result in about $10,000 at the end of this thing. So as you can see, if you make good decisions over time, there is a chance that you'll improve upon just leaving your money in the stock market and letting it grow over time. What it does next is it uses the current time step value of the decision value matrix and says, hey, where is the maximum value associated with this current time step, and what cutoff is associated with that value? And then it finds whatever that value is and then associates that with the percent that it just received. If that percent is greater than the optimum percent cutoff, it pulls the money out of the stock market for a 24-hour period. If not, then it leaves it in to receive whatever gains those are. Here's an example of this logic performing very, very well. It converges very soon at roughly around the 250 mark in the lower left-hand corner, flatlining the decisions over time. In the lower right-hand corner, you can see how this converges to a single global optimum point that it chooses every single time. In the upper right-hand corner, you can see how making these good decisions, these optimal decisions over long periods of time can have a substantial impact as your overall gain on the 10-year mark. In this case, the no train value, which is the value that starts making these logical decisions on day 3, outperformed all the ones by about 10x compared to the whole value. Here's an example of it having a hard time in the beginning figuring out what decisions it should be making. And the lower left-hand corner, you can see how it's very erratic decision-making nature. In the beginning, roughly around the 500 time step mark, it starts flatlining and starts making very, very good decisions over long periods of time. If you look in the lower right-hand corner, you can actually see this convergence to roughly 3 local optimum values that sort of oscillate between the global optimum status. Because of this early non-convergence and later convergence, the 5-year train data set, which was what we would use in real life, far outpaced all the other ones at roughly 6x increase from the whole value status. Here's an example of this bot performing poorly. Over time, lower right-hand corner, you can see how it starts developing multiple local optimum decision points. And the bot has a hard time discerning between these points. And you can see how it had started out with a convergence status, a false convergence status, ultimately becoming incredibly erratic, resulting in lower values in the 10-year mark. In order to combat this, it is a future research is required to see if Gaussian and rinse and fits for decision distributions to see if the sum squared error for those distributions by choosing points that would minimize the sum squared error, if that would ultimately reduce the erratic nature of the training bot, as is the case in the DG function. In conclusion, I found out that you can absolutely gain an edge on the stock market if you do very well-informed decisions on a daily basis. These values are based on the CRUS stock over a 10-year period, starting with a $1,000 initial investment and then $100 every month thereafter. You can just see how this sort of blows up if you make these good decisions over long periods of time. That concludes my brief, and these are my references. Thank you.